Okay, so this is the question from the last class that we did. So, mechanics question, inclined plane, has friction. So where do we start? We start the first point with a diagram. So let's put all the information in this diagram. So it's inclined. So I've got my normal reaction perpendicular to the plane. I have got my gravity vector, which is going to be 2g. And that is at an angle to the vertical of 30 degrees. Okay, I've got tension pulling in this direction at an angle of alpha. And I have got friction acting in the opposite direction, like that. Okay, because it tells me that it is on the point of slipping up the plane. So it's on the point of moving in that direction, but at the moment it is not moving. Right. Okay, so let's start. So we've got a diagram. Next thing. It's a rough plane, so I need to find the normal reaction. So we're looking in the vertical plane. Okay, so I've got R going up. I've also got this force, this tension force going up. Now, it's measured at an angle of alpha to the horizontal. So to the vertical, it's going to be sine of alpha. Now, I've got the other force I've got the gravity vector going down to g. That's at an angle of 30 to the vertical. So that's 2g cos 30. And my object is not moving in the vertical plane, so therefore that's equal to 0. Okay, so that means that R is equal to 2g cos 30 minus t times sine of alpha. Okay, now I'm given a bit of information. They tell me that tan of alpha is 3/4. So I can draw a right angled triangle, and my alpha, tan is 3/4. So tan is opposite over adjacent. And from simple Pythagoras, I know that means my hypotenuse is 5. So it also tells me that sine alpha is equal to 3 over 5, opposite over hypotenuse. And my cosine of alpha is 4 over 5. Remember to draw the triangle. It'll prevent you from making silly mistakes. Okay, so now that means up here, I can substitute sine alpha. I also know the value of cos of 30. Now let's rewrite this. So R is equal to 2g. Cos 30 is root 3 over 2. And then I'm subtracting t times sine of alpha, which is 3/5 of t. Well, as you can see, I've got a 2 and a 2, so I can cancel those out. And then I've just got this left as my R. Right, so now I've got that. Next thing I need to do, I need to think about moving up the plane in the direction of movement. So what forces have I got? Okay, so I've got tension pulling it. So that's T, but that's at an angle of alpha to the horizontal. So that's T cos alpha. I've got friction trying to stop it. And I've also got the gravity vector trying to drag it down the incline. 2g. Remember the angle is 30 to the vertical. So that's 2g sine 30. And also this time as well, it isn't moving. So that's 0. Okay, again, we know what cos of alpha is, and we know what sine of 30 is because they are just values. So let's rewrite that. That means that t times cos of 30 is 4/5 of t. Okay, I'm going to put friction in a second. And then I've got minus 2g sine of 30. Well, sine of 30 is or I'm going to put cos of 60. Okay, but anyway, either way. So I've got 4/5 of t minus sine of 30 is a half. Sorry. So I've got 2g sine 30 equals, and again I've got a 2 and a 2, so that's just g. Okay, now our friction. This is the important part. This is the new bit. So I want to put friction into here. And I know that friction is mu times r. So mu times r. Mu, I'm told, is 1/3. So mu r equals 1/3 of r. Right, let's sub that in. That gives me 4/5 of t minus 1/3 of my r up here, which is √3 times g minus 3/5 of t, and that's equal to g, which is this. Okay, so all we've done is taken that to the other side. Okay, now I can expand out my brackets and do 1/3 times 3/5. So I'm going to add 1/5 of t, and I've already got 4/5, so that gives me a whole t. I'm subtracting 1/3 of √3 times g. And I've got t minus 1/√3 times g equals g. If I rewrite that, t equals 1 plus 1/√3 times g. And that is the tension in the rope as requested. Okay, so just bear in mind, make sure that all the forces are on your diagram. That's number one. Find the normal reaction if there's tension. That's number two. Then we go to F equals MA in the direction of movement. That's 3. Then we find the friction, which is mu r. That's 4. And finally, we rearrange to get the answer in the form that we want, which is 5.